Hi everyone, my name is Frank Gonzalez,
And I'm Robbie Cato.
and our project is on manipulating and grasping industrial tools. Nowadays, manufacturing is turning more and more towards automation, using robotic systems to efficiently create high-quality products. In order to support this effort, we investigated creating a system that could autonomously grasp a tool in such a way that it was ready to use. For this project, we simulated a KUKA IWA 7 arm with a general WSG gripper and two tools, a hammer and a screwdriver, to demonstrate the capabilities of our project.
This block diagram shows the overall robotic system we implemented, with the two red boxes indicating modules that were not fully integrated. For this project, we developed a stack using mask, RCNN, and ICP for pose estimation, and an inverse kinematic solver for state determination. Ideally, we would use a decision maker module to choose which tool to pick up. However, with there only being two tools in this situation, the decision maker was deprioritized and thus not implemented. Regardless, the key poses were passed to Slurp for generating pose trajectories. We end by passing the computed state trajectories into the simulator, and Frank will show the results from just this block, with everything else being pre-computed.
In these two videos, we can see the end result of the full stack implementation, with the robotic arm navigating, grasping, and lifting the hammer on the left, and doing the same for the screwdriver on the right. Here, we can see a slightly different perspective on the grasps after the IWA arm has come to rest. From these images, we can know that these are indeed usable grasps and not a random grasp on the tool, putting the system in a prime position to continue forward with whatever task it might be provided.
One key pitfall we had was the mask RCNN model. The image on the left shows the top 5 bounding box results from our model, all of which are labeled as scissors and many of which don't capture the full extent of the tools. This is likely due to the images we used to train the model. An example screwdriver from one of the datasets is shown on the right. The images in that dataset were close cropped and rarely showed the full tools, just like the hammer handle here. It's also important to note that scissors were the most represented object in that dataset as well. And this highlights the importance of finding training data representative of the expected environment. In our case, a cluttered table with most of each tool pictured. A critical next step for this project would be to generate our own training dataset in the simulation. The new dataset would likely give better labeling and segmentation results that could be fully used to integrate mask RCNN.
Briefly touching on some of the lessons we learned throughout this project, for starters, over time, we both definitely became more comfortable working with the Drake environment. At the beginning, there was definitely some bumps along the road that made getting started pretty challenging, but once these were overcome, progress became much smoother. As for me, I learned quickly that sometimes simpler is better. I ran into several issues trying to create proper definitions for the tools, resulting in awkward physics simulations due to incorrectly defined inertials. This difficulty came from using awkwardly defined links and trying to determine the inertials myself, which didn't go well at all. The moment I switched to simple geometries, everything worked much better.
And that summarizes up our project. Thank you for listening to our presentation.